Okay, so on this session, we talked about mainly two things. We talked about the Pythagorean Theorem, and we talked about the difference between mass and weight. So the first question we had was that there was a plane that was, let's say the plane is represented by this dot here. It is flying south at 250 meters, 250 kilometers an hour. Okay, so let's pretend that the down arrow represents south. And we're also given that there's a wind blowing from the east at 30 kilometers an hour. So since it's blowing from the east, it would be blowing west. And so it would go here. And then that would be 30 kilometers an hour. And the question is asking you to find the resultant vector of the plane. So if I have a plane that's flying south, if there's no wind acting on it, it'll be flying south in a straight line the entire time. But because we have a 30 kilometer an hour wind acting on the plane, it's not going to fly in a perfectly straight line. It's going to fly a little bit to one side because the wind is acting on the plane. So the way we represent this resultant vector would be connecting the start point here with the end point of the two vectors added together. And the arrows are the vectors. So basically, if we find the length of this resultant vector here, that would be equal to the resultant velocity of the plane. So the way we did that is we use Pythagorean theorem. And as you know, Pythagorean theorem is a squared plus b squared equals c squared, where c squared is the hypotenuse. And the hypotenuse is the side that is opposite the 90-degree angle. And we know from this diagram here that this is the 90-degree angle here, and the side opposite this would be this one. So this is our C side, and we're trying to find that. So A and B, we can do any of these. Let's say 30 would be our A side, so 30 squared plus 250 squared equals C squared. And if we do the math on this one, let me figure that out. It'd be 30 squared, which is 900, plus 250 squared, which is 62,500. And then that would be equal to our C squared. And then if we add that to 900, we get C squared equals 63,400. And to find what C is, we would square root both sides. And that is equal to 251.8. And kilometers per second or per hour. So that is what this is over here. This is equal to 251.8 kilometers an hour. So anytime you have a question that's asking you to find resultant vectors, always draw a diagram, because diagrams are how you're going to figure out how to solve for the final product. We drew the diagram here and we realized that it formed a triangle, so we need to use the Pythagorean theorem to find out what the last side is. So yeah, in other words, this means that the plane that's flying 250 kilometers an hour south with a wind acting west on it will be flying at 251.8 kilometers an hour in that direction, in a different direction, basically, because the wind is blowing on it. So yeah, hopefully that helps on that aspect. The second thing we talked about, which took up the majority of the time, was the difference between mass and weight. So we were given that we know that force equals mass times gravity. And More specifically, the force in this context would be equal to weight. Weight is a force. So let me actually type this, that might be easier. So weight is force. It's a force, okay? And mass is how much matter something has. So if we wanted to make a chart here on the differences between force and between mass and weight, let's see if I can do that. Mass on this side, we have weight over here. So one aspect of mass is that it is the same no matter where you are in the world. Okay? And that's because mass is the amount of matter or the amount of stuff that something has. Whereas weight depends on where you are. Your weight on Earth is not the same as your weight on Mars because Earth has a higher gravity. The Earth pulls you down, and so your weight will be greater than your weight is on Mars because Mars's gravity isn't as powerful. So, but your mass on Earth and Mars will be the same because you have the same amount of matter in you everywhere. Okay, and remember, matter is the amount of like stuff that you have matter. Okay, and then weight is it relies on mass. The more mass something has, the more it will weigh on the same place. And then some examples of what mass is equal to is you could say it's grams, kilograms. There's other things, but that doesn't really matter right now. Okay, and then weight are things like newtons, which is a measure of force. Newtons, pounds, yeah, other things like that. And the reason why it's really confusing for a lot of students initially is because we're used to like in other countries other than America, people say like, oh, I weigh 100 kilos. But in America, we say I weigh 200 pounds or whatever. And that's confusing because we're grown to think that those are like the same kind of thing. They're both weight, but and we're taught that mass and weight are kind of the same thing, but really they're different because the reason why we don't care about it is because we live on Earth our entire lives. So mass and weight will pretty much practically mean the same thing, but in science, it's different because your weight on Earth will not be the same as your weight in space. Your weight in space will be 0 because there's no gravity in space. And your weight on Mars will be like a decent amount, but it won't be the same as it was on Earth. And your weight on Jupiter will be, I think it's like twice your weight on Earth because Jupiter's a massive planet. But your mass everywhere is the same, okay? And that's the important thing to realize is that on one of the questions it asks, the rock weighs 7.45, or the rock has a mass of 7.45 kilograms. How much does it weigh on Mars? What would we do? What we would do is we would find the mass, which is 7.45, times the gravity on Mars, which they gave us was 3.72. And that gave us some answer. What was it? It was 27.71. And that would be 27.71 newtons. And that's our weight. So, but we saw that if we took the same problem, or took the same rock, and we put it on Earth instead, the equation would be the same, except because Earth has a gravity of 9.8, the weight on Earth would be vastly different. It would be 73 newtons, basically. Okay, And so that's a perfect example. The rock has a mass of 7.45 kilograms in this one, and or in this one, because it's the same rock, but it has a different weight on each planet. So it's kind of confusing, but I hope that helps. Um, and also the last part of the question, which is kind of tricky, was determine the mass of the rock on Earth and explain your reasoning. And we determined that the mass of the rock on Earth was 7.45 kilograms because mass does not care about where you are. It's the same everywhere. I have the same mass in the entire universe, but will have a different mass, a different weight everywhere I go. So that's the most important thing you want to take away from these things. Um, this equation is really important to know if the weight is equal to your mass times the gravity on the planet you are on. Okay, so more specifically in this equation, this would be equal to weight. Okay, but weight is a force, so that's correct too. So I hope that helps, and I'll see you next time.